already know that you all guys are now preparing for GATE 2024. Okay, so GATE 2024, that simply means you have to now work on your concepts, build your concept clarity, because if you try to see last year or last 2 years of paper of GATE, they are being persistently asking from the conceptual topic. Okay, if your concept are strong, then you'll be able to you'll be able to solve question, and you'll be able to grasp the very easy marks from these subjects. Specifically, if I talk about engineering mechanics, very important, both for civil and mechanical, right? In the last 2 or 3 years, the question from the engineering mechanics is very good level of question is being asked. It's not a direct, straightforward, single line or single formula based question, right? They'll be only asking you some conceptual base. And the recent trend, if you try to see, they're asking the mixture of subjects. Okay, that means some topics from your mechanics, some from other subject. They're clubbing that and they're trying to ask. So for that, you all know that scholarship test plays a very vital role in the long journey towards the preparation. So on 30th of April at 12 p.m. we'll be having the scholarship test where you can get up to 90% of scholarship. So try to avail the scholarship and try to get benefit of this. Okay. Saw you in Haridwar in 1.5 months ago. Okay, I might be. Yes. I think 1.5 months ago, might be possible. On weekend, I think I went on weekend, 1 day trip. So it is only 4 hours from my place. So you might have called me. We could have a discussion, right? Okay, fine. So shall we begin? Good evening. Good evening. Very good evening, all of you. Chaliye. So now, as you know that mechanics is a very interesting and important subject, so we'll be dealing with the understanding of the concept. Okay. So this starter series is planned in such a way that we'll be understanding the concept first of all. Then we'll be having one practice session, because without practicing, you won't be able to have that upper hand on this subject, specifically this engine mechanics. Okay, so now if I try to talk about what is engine mechanics, if I say mechanics is broadly classified in two categories. One is your static, second is your dynamics. All of you know that. And statics we have already studied in ground zero also. Now what is static or static equilibrium? Basically means the body will be in the rest condition. In simple one-liner, what if I say static condition means the body will be in rest condition. Let's take one example. Let us suppose I'm having a body. I'm applying a force. The body is not moving. That means the body is in static condition. Okay. There is one more case that I'm trying to apply the force. Okay. I'm trying to apply the force. But what is happening is I'm just pushing that body. I'm just releasing that. It's like this. There's a body. I'm just having a force and it is moving with some velocity. Right. So that analysis what we're discussing is in kinematics. Right. If I say dynamics means the body is in motion. So dynamics is further classified into two categories. One is your kinematics and second is kinetics. Kinetics basically means when the force that we are applying, the cause, if I say in a one-liner, what is force? What is force? Force is basically equal to mass into acceleration, right? Now, how this particular equation is coming into existence from the Newton's second law. Now, what do we call this? This is basically the cause of motion. Okay, this is cause and this is, we call it as effect. Due to the force, acceleration is coming into existence. It's not like this, due to acceleration, force is coming to existence. No, due to the application of the force, the body is having some acceleration. And what do we call, what is this M called? Anyone who can tell me? I just discussed many times this kind of session, this concept I've already discussed. What is the meaning of this M? Don't tell me this is mass. Tell me in a simple word. If I'm saying that F is cause and acceleration is effect, so what is mass called? Mass is nothing but resistance to change in a position. Okay, fine. Resistance to change, that means if a body is having a larger mass, it will be having a large inertia, right? You will need to apply a large amount of force in order to change the position. Right, so force is equal to mass into acceleration. This is a very important, and entire engineering mechanics is revolving around this particular equation. And this is basically coming from a very beautiful theorem, that is Newton's second law. Newton's second law. Okay, so now if I try to classify mechanics, it is classified into two major portions. Statics means when the body is at rest, when the body is at rest. Okay, dynamics means when the body is in motion, right? Now it won't be an appropriate statement if I only say that the body is at rest. I can say when the body is moving with constant velocity, when the body is moving with constant velocity, this is also being considered as a static condition. Okay, Grambel, buffering, please do check now. I think that is no problem now. Initially there was some problem, now I think that is being rectified. Okay, yes, all good to go, right? So now we can say static condition can be considered as when the body is at rest, or when a body is moving with constant velocity. Because when velocity is constant, what's the meaning of this? When velocity is constant, can we say that the linear acceleration will be tending to zero? Because what is linear acceleration? Rate of change of linear velocity is your linear acceleration. Okay, fine, clear. So when the body is moving with constant velocity, or when the body is at rest, that will be considered as a static condition. Then what is dynamic? Dynamic means the body will be in motion, and that too will be having an acceleration. That will moving with some acceleration. Okay. Now what is kinematics and kinetics? If I talk about kinetics, kinetics means what will be the cause, that will also be considered. That means force is considered. Force is considered under discussion. Okay, fine. In this case, force will be considered when we'll be trying to apply, when we'll be trying to have any discussion. Force will always be taken into consideration. In kinematics, we are applying the force, and after that, how the body is reacting to that force, that will be discussed under kinematics. So our topic is kinetics, under which we'll be talking about this in detailed discussion. Now, kinetics is basically further classified into two categories. If I say kinetics is further classified under two segments. One is the kinetics of the rigid body, and second is kinetic of the particle. Okay, basically it should be particle only. Now what is the meaning of this word kinetics of rigid body? Rigid body means, in this case, I'll be considering the shape of the body also. Shape and size of the body will be considered. That means if a body is spherical in shape, it will be having different analysis. If a body is in ring shape, if a body is having a triangular shape, that means the same shape and size is also being here. In particle analysis, what we do, we are only having the mass taken into consideration. That's it. That is independent. That means do we have a circular body? We have we can say disc or a ring, right? So it is immaterial. So whenever I'm talking having discussion of the kinetics of the rigid particle, or simply we can call it as the kinetics of particle, there will be only considered about the mass, irrespective of what is the shape and size of the body. Okay, fine. So now if I say, to understand the kinetics of rigid body or rigid particle, there are three approaches that we need to have to solve. Because what is the main motive? Main motive is we need to calculate the value of force, or we need to calculate the value of acceleration. That means we have to create a relation between force and acceleration. So for that, there are three different approaches. There are three major approaches which we can use to create the relation between force and acceleration. What's the first approach? One is your D'Alembert's principle. D'Alembert's principle. Okay. We can have one more approach, that is your work energy theorem, or work energy principle. And we can have one more approach, that is your we can say impulse momentum approach. Impulse momentum approach. Okay, so there are three approaches through which we can formulate the relation between force and acceleration. Because once I'm able to formulate a relation between force and acceleration, I'll be able to calculate very easily the motion variables. What are motion variables? Motion variables means we are talking about velocity, we are talking about displacement, we are talking about acceleration, right? So once I'm able to formulate this relation, I can have three analysis. Either I can solve the question by D'Alembert's principle, either I can solve this question by work energy principle, or I can use the impulse momentum equation. Okay, so in today's session, we'll be talking specifically on this D'Alembert's principle because majority of the question is being solved by using the D'Alembert principle, right? Right. Okay. And what's the basic objective of this and how D'Alembert is coming into picture? Everything will be discussed in today's session. Okay. Fine. So for understanding D'Alembert's principle, let us first understand what is Newton's second law. So please tell me in the comment section, what is Newton's second law? Anyone? What is Newton's second law? You all have studied in your class 12. You all have studied this particular topic in your physics. Now today it's time you guys to tell me what is Newton's second law. Chalo. Anyone? Anyone? Yes. Newton's second law, everyone says that, sir, it is force is equal to mass into acceleration. Right? Everyone will be saying that, sir, F is equal to ma. That's it. Okay. I would rather say Newton's second law is nothing but your, we can say, force is nothing but the change in momentum. Okay. Or we can say the rate of change of momentum. Force is nothing but is equal to the rate of change in momentum or linear momentum. The rate of change of linear momentum, that is your d of m into v by dt, that is nothing but m into dv by dt, or we can say m into dA. This is basically your Newton's second law. What is the meaning of this? That means if a body is having some unbalanced force, let us suppose I'm having a body, right? And over to this body, I'm having, let us suppose 10 Newton, 2 Newton, let's say 6 Newton. Okay. So what is the net force acting on this body? Can we say the resultant force acting on this body will be equal to 6 Newton on the right hand side? Due to this unbalanced force, this body will be having some acceleration, and that is basically your Newton's second law. Due to this unbalanced force, due to this force that is existing on this body, right, some acceleration A, and we can calculate if I know what is the mass of this body, so 6 will be equal to m into A. From that equation we can calculate the value of the acceleration. Very easy. That is your Newton's second law. Okay, that means the total unbalanced force acting on the body, the total unbalanced force acting on the body should be equal to mass into acceleration, where this unbalanced force is the cause of the motion and this is your effect of the motion. Okay, or we can, this is the effect, right? If you try to apply a force, how the body is responding, that is the effect that we are talking. So in this particular analysis of kinetics, our main objective is to create a formulation between force and acceleration. Okay, so now you'll be asking me, sir, what is this D'Alembert's principle? Okay, we always talk about what Sir D'Alembert's principle. Let us talk about this D'Alembert principle in a very simplest way. Okay, let us suppose I'm having an arbitrary body, right? I'm having an arbitrary body and this body is moving along this x direction. Okay, it is moving along x direction, right? There is no y direction axis. That means your acceleration along y direction is 0, right? So can we say there will be some net amount of force? Let's say the net amount of force along x direction, it is definitely not equal to 0, the horizontal force, right? Due to this net horizontal force, there is some acceleration of the body in the horizontal direction or in the x direction, right? Okay, now, and what will be the magnitude of this? This x direction of force will be equal to mass into the acceleration along x direction. Okay, now if I try to understand, let us suppose if I write it like this, fx minus m into ax equal to 0. Now if I try to assume that this is a new hypothetical force, I'm saying this is fx minus a force that is F5, we call it as inertia force, right? That means now can I say on this body, if I try to apply a pseudo force exactly opposite to that of this Fx and equal in magnitude, now can I say this body is in equilibrium condition, or we can say dynamic equilibrium condition? Yes. That means if I want to make this body into a static or an equilibrium condition, that means the body should be at rest, I have to apply exactly equal force opposite to that of MA, or that is the unbalanced force. And this force we call it as a pseudo force that is not real, right? This is a pseudo force that I'm talking about. This is the pseudo force that we are talking about. Okay, fine. So from here I can say if I want to make this body equilibrium, because to do the analysis of equilibrium is very easy. Whenever we try to do the analysis of any equilibrium condition, it's very easy. That is the reason we always try to frame a equilibrium or dynamic equilibrium condition. We can say net force acting on the body equal to 0. Right? So if I'm applying a pseudo force on this body exactly having the same magnitude as that of Fx, then I can say the body is at rest, and this is basically your D'Alembert's principle. This is basically your, that means if I say on this body, this is the net resultant force acting on this body, then I have to apply exactly equal magnitude of that of Fr, that is your inertia force, that is your pseudo force, and that is your D'Alembert's principle. Okay, fine. But is that the same thing that we have discussed in Newton's second law? In the Newton's second law, we have discussed the same thing. Only difference is what we are doing is we are just having a new hypothetical or a pseudo force due to which the body is at rest, right? But ultimately you will be always be getting the same result, this one. So my personal suggestion will be, is sir, always apply the Newton's second law, because that is basically the best method. In D'Alembert, there is one problem students do face. What is the problem? They are not understanding the direction of the inertia force. Many times this is a simple situation, right? When we'll be having a multi-pulley system, okay, or a problem of lift, so there might be, you won't be able to have a clarity in which direction this inertia force should be acting, right? So to make this a simple, a very easy approach, what we do, we try to have a simple, that is Newton's second law, right? That means whatever unbalanced force, what is the net force acting on the body, that should be equal to mass into the linear acceleration. Mass into the linear acceleration of the body. Okay, let us try to take some examples so that we are having more understanding how to apply this Newton's second law in different applications. Let us suppose the very basic, the pulley system. Okay, we'll be taking one more example of pulley system. Now, let us suppose I'm having two masses connected with a single pulley, and this pulley is massless and frictionless. Okay, here it is connected with a single string. It is connected with a single string, right? So whatever acceleration will be having M1, the same acceleration will be that of M2, right? So if I try to draw the FBD of mass M1, basically it should not be FBD, right? So if I say M1 will be having M1G acting downward, will be having tension T acting upward, okay, and the acceleration is downward. Can we say that what's the net force acting on that body? The net unbalanced force acting on that body is M1G minus T, and due to this net force, the body will be having an acceleration due to, according to Newton's second law, this unbalanced force will be equal to M1 into A. So from here I can say M1G minus T is equal to M1 into A. Okay, by using a simple, we'll be starting first of all, we'll be taking a basic example, then we'll be taking some complex situation, right? Okay, today we'll be talking about only the concept, we won't be taking any question. Practice session is being scheduled on Saturday, don't worry about that. Okay, we'll be taking a very good level of questions, majorly from your equilibrium, your kinetics, right, and your this one work energy principle also. Okay, fine. Now if I talk about this is FBD of mass M1. Now if I talk about the free body diagram of mass M2, right? So M2 will be having a weight acting downward, that is M2G will be having T, and a net body is moving in the upward direction. Okay, so can we say what is the net unbalanced force acting on this body? That is equal to T minus M2G, and that equal to M2 into A. So we got two equations, we are having two unknowns, that is T and A. We can easily calculate this tension and acceleration in this particular pulley system. Okay, let us take one more example. Let us suppose I'm having a situation like this. Let us suppose I'm having a situation like this. Let me do one thing. Now you guys will be telling me how to proceed to solve this question. This is M1, this is M2. Chalo. Let's see. Let's say this is moving with some, I'm assuming this M2 is more than that of M1. Okay, M2 is moving down with some acceleration A2, is moving some acceleration A1. Okay, now can you tell me what is the relation between acceleration A1 and A2? This is the most important task. Okay, if you're able to understand this, problem is solved. Let us suppose M2 is more than that of M1 and M2 is moving downward with an acceleration of A2 and M1 is moving upward with an acceleration of A1. So what is the relation between A1 and A2? And if I talk about that, your tensions will be having tension, let's say T, or let me take it as 2T. This will be 2T. Here we'll be having T, T, right? This will be T. Okay, fine. So we have drawn all the forces acting on this particular body. Now, what will be the relation between A2 and A1? Now, for understanding this, it's a simple technique. If let us suppose I'm moving this pulley from this point to this point, it is have reached this position. That means it has moved a displacement of x. So if this is moving from this point, so definitely from both the side, here also and here also will be having x and x. It has to move, that string has to move downward. But as this is fixed, can we say this x will be shifted on this side? So on this particular string, 2x will be the displacement on this particular string. Due to this 2x, this m1 will be moving upward with a displacement of 2x. Yes, that means m2 is moving downward with x displacement, m1 will be moving with a displacement of 2x. Can we say it will be having an acceleration of twice a, it will be moving up with a twice a acceleration, and this is moving with a downward with an acceleration of a. Okay, so now let us try to draw the FBD, free body diagram of M2. If I draw the FBD of M2, M2 will be having, this is your M2G, right? This is your 2T, net acceleration downward. So I can say, what is the net unbalanced force? Net unbalanced force is M2G minus 2T. And according to Newton's second law, this is also equal to mass into acceleration. First equation we have created, right? So we'll be having M1, right? We'll be having T, we'll be having M1G, we'll be having acceleration of this is twice a upward, right? So by doing this, we can say T minus M1G is equal to M1 into 2a. So by this way, I'm able to create two equations where only two unknowns are there, T and a. I'll be able to solve easily and get the value of a and t. Is this clear? Right? Can we take one more example from pulley system? Then we'll be taking one example of lift wall example, right? And then we'll be taking one inclined system also. Okay, chalo, let's take one more example. Let's take one more example. Okay, so here we are having mass connected, not this one. We can say, okay, having a pulley, so mass M1 connected, okay. M2 and M3. Okay, chalo. Now tell me how this particular strings this will be moving. And now M2 is being supported by these two strings. This pulley number 2 is a frictionless and a massless pulley. Now, if I try to visualize, if this is moving downward with some acceleration a, this string and this string both will be moving some acceleration a, I can simply say this both masses M1 and M3 will be moving with an acceleration a. Very easy. Is this clear? Understood? Now we can apply the Newton's second law and formulate the relation and get the answer. Like over here, if I try to visualize, we'll be having 2t, this will be t and t, right? This will be t, okay? This will be m3g, this will be m2g, this will be m1g, okay? Take individual masses separately, do the analysis, write the Newton's second law. What is Newton's second law? That is unbalanced force. Calculate that unbalanced force. That should be equal to mass into acceleration. That's it. That's it. Okay, fine. Is this clear? Okay, let us take one more example, the motion of lift. Because majority of time you are getting questions like this. So definitely this weight will be, this lift will be having a weight of, let's say, mg, right? And this is the tension T. Now the lift is moving, let us support upwards. There's an upward movement of lift. Upward motion of lift. Okay. If the lift is moving upward, can we say this moving some acceleration A? I can say T minus capital mg is equal to capital M. That's it. This is motion of lift. We can do the analysis very easy. Only we have to do is what is the net force acting on the body. Once we are calculating the net force acting on the body, after that just we have to apply the Newton's second. That's it. This particular approach will be used in almost all type of questions, right? We can introduce the friction also. Okay, let me take the friction also taken into consideration. Let us suppose I'm having an inclined system. Because friction we have already studied, right? So it will be very easy for us to do the analysis. Okay. Now, the body is sliding downward with some acceleration A. And this having some friction, kinetic friction is also being given. Kinetic friction. Okay. Friction coefficient. This is also being given, right? So what we can do the analysis. We can say this will be your mg cos theta. This will be your mg sin theta, right? Normal reaction, the friction force, right? So we can say along the direction of motion, what's the net force acting? So we can say the net unbalanced force along the direction of force will be equal to mg sin theta minus the frictional force, the kinetic friction, right? This will be equal to mass into acceleration. Okay. So what we have did, along the direction of motion, this is the direction of motion. What is the net force acting? And due to this net force, that unbalanced force will be having some acceleration, that is Newton's second law. This can be applied in almost every different applications. Okay, wherever the shape and size is not being considered. Okay, when the shape and size would be considered, then we talk about the kinetics of rigid body. There we have to take the moment of inertia also. If the body is having a rolling motion, then we have to take is it a disc or is it a ring, then we have to consider that moment of inertia concept also. But here, because we are talking about the translatory, or we can say the rectilinear motion, so there I think that is very easy to do the analysis. Fine. Is this clear? So today we have talked about the very important concept of D'Alembert, but major agenda, the more motive is to study about the Newton's second law, right? So now you can apply the concept of Newton's second law in n number of applications, so that we can have the complete problems will be solved in a most easiest way possible. Okay, fine. So this startup series has been started from 18th of April. Already we have covered, I think, fluid mechanics. So today we were supposed to take more, but due to some technical issue in the starting, we were not able to start at appropriate time. Okay, fine. So we'll be now meeting day after tomorrow, where we'll be having the discussion of very important concept. We'll be having discussion of the work energy theorem. Okay, second very important, work energy principle or theorem. We'll be discussing this work energy principle on today's Tuesday, right? So Thursday, same timing, that is 10 p.m. After your dinner, just do join me on Thursday. For UPSC CSE best book for EM numericals, for UPSC means you are talking about. We can have previous year question. First of all, the first preference will be, because many times the previous year question is being very important. You can take this your civil service previous year also. There also we are having the mechanics questions, right? And there are some good level of questions where multiple concept is being used. Okay, so you can go for that also. That's only. You can take the ESE means problem. You can take the civil service means problem, right? Why I'm saying means problem, because many times means problems will be helping you to understand the concept. Okay, from objective perspective, you can take any, you can take the gate also, you can take the civil service. ESE is prelims is very less lower level from mechanics perspective. Yeah, gate or mains, ESE mains paper or civil service mains paper, try to take the previous year questions. The 5 years more than sufficient, because sometimes they're asking a good level of question. Even in gate also, one or two times they are asking a very good level of question from mechanics. So you can do attempt that also for your best. Best book is like Hibbler only. The best book is for mechanics is Hibbler only. No doubt in that. Okay. Hibbler is the best book if you are following that. But thing is, if you're directly starting from that, might be it will be difficult to solve the question. You start with a basic level, then try to apply the question. Like start with the solved example first of all, right? In Hibbler, you will be having some solved example. Try to go for that, then you can go for that exercise problem. Okay, and if you're following Hibbler, I think you will be able to cover mechanics very appropriately, and that will be helping you in strength of material also, and some portion of theory of machine. I'm not saying the entire theory of machine, but some portion of theory of machine is also being useful by studying the mechanics in detail. Okay, so that is being directly related, right? Engineering mechanics, majority strength of material, some portion theory of machine. So it's very important, if you're having a strong command over engineering mechanics, you'll be able to have better understanding. Okay, I'll be sharing this PDF on this my Telegram channel also. You can do join that, and let's meet on Thursday, right? Let's meet on Thursday and talk about work energy theorem or work energy principle. 25 minutes or half an hour, not more than that, because that is a topic which we can understand the whole concept in 15-20 minutes. But we'll be taking some examples also. We'll be taking some doubts also from your side, so that we can work on that. Okay, fine. So thank you guys for joining with me. I hope you all enjoyed, and let's meet on Thursday on your own. That is BYJU'S exam prep. Thank you guys. Bye bye. Take care. Stay safe and enjoy your day. Thank you. Good night. Bye bye.